E2 over lambda 1 minus lambda 2. Yes, you just use this over this equals, if you just draw like this, will be this one over this one. Yes, this one will be E1 plus E2, and this will be, now there is no screen display on test meeting. I think the test screen is okay, because you see here the screen is shared with you. Maybe the internet connection is some errors for you. So let's continue. E1 over lambda 1 minus lambda 3 equals E1 plus E2 over lambda 1 minus lambda 2. So based on this, you will know how to solve lambda 3. So lambda 3 equals lambda 3 equals E1 lambda 1 minus lambda 2 over E1 plus E2. Here minus plus lambda 1. Yes, you can got how to calculate lambda 3. That means based on lambda 1, lambda 2, and E1, E2, you can calculate lambda 3. Okay, that means if you guess lambda 1 and E1, lambda 2 and E2, how to calculate lambda 3? Just like this. Okay. So the procedure for this for the iterative procedure to solve the equilibrium dispatch is like this. First, you guess the lambda and calculate the pi based on this lambda, and then you calculate the error between the total load and the total generation. This is the first iteration. If the error is smaller than the tolerance, that means that the total generation is very near p-load. That means they almost match, so you can stop and end the program. Otherwise, you should update the lambda and continue for the next loop. Means that you update lambda by the interpolate or extrapolate, or just directly increase or decrease 10% of the first value. Then you continue for the second loop. Okay. So the procedure can be adopted for a computer implication. First, implementation of the power output calculation is rather dependent on the solution method. That means that when you calculate dFi, dPi equals lambda, because you guess a lambda, because you give a guess value for lambda. So when you calculate this equation for pi, you can use any method to solve pi. Okay. As an iterative procedure, a stopping query must be set up. That means this is a loop. You should set up a criteria to stop the program. There are two criteria to stop this program. First is the total power output is very similar to the total load. That means this error is very near zero. That means the total generation is near the total load. You can stop the program. Otherwise, the second rule to stop the program is the maximum iterations exceeds a maximum value. That means the maximum iterations has reached. For example, you set a maximum value for the iteration number is 10. After 10 iterations, if this condition not satisfied, the program may stop for this solution because it reaches the maximum iterations. Okay. Okay, let's say example. Here we consider three generators to supply a load of 2500 megawatt load. Okay, I will show how to use the Lambda iteration method, just as I mentioned. This is the input-output curve for the heat. Okay, if you multiply this heat input-output curve, you will get the fuel cost input-output curve. Okay, just multiply this by 1. Okay, you will got the F input-output fuel cost. Okay, that means Fi. You will got Fi Pi. Okay, so our problem is to find the minimal summation of Fi Pi from 1 to n and separate the total load of this. Okay, this is our problem. First, we should get the value of lambda. In the second step, do you remember? We should get the second guess the value of lambda. Okay. So set the value on the second iteration at 10% above or below the starting point, depending on the sign of the error. That means first you guess a lambda 1. You will got the error lambda 1. If the error I from PI
वो लेंथ निकालनी
PI
अच्छा वो काउंटिंग के हवाले से कह रहे हैं काउंटिंग के हवाले से नहीं वैसे डिफाइन इसमें 10 से ज्यादा उसका नहीं होना चाहिए डिस्टेंस
sigma PI, this is total load. If this error is positive, that means the total generation is too large. You should decrease the lambda by 10%. If the error is negative, that means smaller than 0. That means you should increase the PI. So you should increase lambda by 10%. Okay, this is for the lambda 2. How to calculate or update the value for lambda 2. Okay. After you have the value lambda 1 and lambda 2, you should update lambda 3, lambda 4 by the extrapolate or interpolate method. Okay. So let's see how to solve this problem. First, we get the lambda value as 8. Then you will calculate the P1, P2, P3 based on increment cost. For derivative 1, increment cost were the first order derivative of F1. Based on this input-output curve for F, you can easily calculate the first order derivative. Okay, this is the first order derivative. Because you have A plus BP plus CP squared plus D P cubic. So the first order derivative will be B plus 2 multiply CP plus 3 multiply dP squared. Okay, you see, will be B 2 multiply C P1 plus 3 multiply D multiply P1 squared. You see, okay, because this is the derivative ones B, C, D coefficient. You see, okay, you see here. So similarly, for derivative 2, you can calculate the first order derivative will be B plus 2 multiply this multiply P2 plus 3 multiply this multiply P2 square. Okay, that's P2 square. Okay, similarly for derivative 3. So that means lambda equals 8. Okay, equals 8. So based on this, you can calculate the root of this equation, and you will find P1 has 2 solution, P2, P3. And because the generation is always greater than 0. So this is not possible. This minus is not possible. Okay. So for P1, we'll keep this value, P2, and this is for P3. So we can calculate the total generation and compare the total generation with the total load, 2000, 1500, and 500. Okay, so 2500 minus P1 minus P2 minus P3. There is error 700, more than 700. That means the total generation is too small. So in the next step, how to calculate lambda 2? Because for lambda equals 8 is too small, the total generation is very small, is smaller than the total load. So for lambda 2, you should increase lambda. Okay, so with a positive error, we should increase lambda by 10%. Of course, you can set here, maybe you can increase lambda at 5%. It's just a suggestion. You can use other percent as you like. Okay. In this example, we just use 10%. Okay. Based on this, you just know you have to increase lambda. So how much you want to increase? It depends on you. Okay. So for lambda 2, if we increase 10%, you will got the new value of lambda 2 will be 8.8. Okay. Based on this 8.8, you will got the new value P1, P2, P3, just like this. Here, 0.8. Okay, 0.8. You will got the updated value of P1, P2, P3. Okay. So for the new updated value of 8.8, you will got the new value P1, P2, P3. Okay. The negative is impossible. Okay. Negative is impossible. So you will update the error between the generation and the load. Here you found this is a negative. That means the total generation is too large. You should decrease the generation. So using the extrapolate or interpolate method to find the new solution of lambda, just based on this. Okay, will be lambda 2 minus lambda 1 over lambda 1 minus E2 multiply E2 plus lambda 2. You found that this is a little different. The little different as I read, because for extrapolate or interpolate, maybe you can use this over this, or you can use this over this. And there are various, there are different expressions, but the physical meaning is the same. You can use, you can choose one type you like. Okay. So for if you have lambda 1 and lambda 2 and E1 and E2, you can update the lambda 3 based on the extrapolate or interpolate method, and you found that lambda 3. For lambda 3, you see is smaller than lambda 2. For lambda 2, that means the total generation is too large. You have to decrease lambda. Here, it's true that you have got a smaller value, lambda 3. Lambda 3 is smaller than lambda 2. Yeah. Continue with this. Okay. That means you just make this equals 0.56 something, and you will got the value P1 also equals 8.56. You will got the new value P2 and P3. You just repeat this procedure. You will got P1, P2, P3, and also the total generation. The total load is 2,500. You found that the total generation is much linear, or approaching the total load 2,500 at 4 iterations. You say it's very near the total load. Yeah, and you will got the update value of P1 and P2, P3. Okay. Okay. Any question for this part? You should keep in mind that first you just guess an initial value for lambda, and you calculate the total generations, and then you compare this total generation with the total load. If the total generation is too small, you have to increase lambda, and thus you will increase the generation. Okay, that's the logic. Okay. Okay, any problem for this?
No, sir.
Okay. And based on this lambda iteration method, and the step is very simple. First, you just guess the value of lambda, and based on the lambda, you will calculate the generation output of each generator, and then you make summation of these generators. If the summation of the total generation is larger than the total load, you just decrease lambda. Then based on the error and the lambda, you can get the new value of lambda based on extrapolate or interpolate method to get the new lambda, and continue these procedures. You will approaching the optimal solution for this. Okay, so that's the logic. So let's continue. For this method, maybe you can say that here. First, we guess the initial value of lambda, and we also guess the increase or decrease percent, maybe 5%, 10%, or 20%. Yeah. The key point is that if you choose different lambda, the iterative procedure will be different. That means if you use 8, here you say there are 4 iterations, you will approach the optimal solution. But if you use different initial point, for example 9 or 10 something, you will got the iterative procedure got a very different iterative procedures. So there may be some issues. And some initial starting point, the lambda iteration approach exhibits an oscillatory behavior rather in a line convergent solution. Means that for 10, if you set the initial value of lambda as 10, you will can't get the convergent solution. Okay, so there's some problem for this lambda iterations. So okay, so next we will introduce the gradient method. The gradient because there are some issues or problem for this lambda iteration method. We will continue to develop a more advanced method. This method is the gradient method. Okay. Suppose that the cost function is more complex. For example, the input-output curve is like this: A1 plus A2, A0 plus A1P plus A2P 2.5 plus A3 multiply E. This is potential function. Because you have an exponential function, so this is very complicated. Also for lambda iteration method, from this you see that you have to calculate the p based on this equation. That means you have to solve p from this equation p1. You have to solve p2 from this equation, and you have to solve p3 from this equation. But however, if this expression is very complicated, for example, you have the exponential functions. It's very difficult to solve the p1, p2, and p3. Okay. That means if you have this, function, it's very difficult to find this. For example, this may be p2. If you have this function, the first order derivative of this is also very complicated. It's not easy to get the value of p2 based on these equations. Okay, so the lambda iteration technique requires the solution of the generated output power for given increment cost. That means you have to solve the generating output based on the increment cost. And the lambda iterative method only possible for quadratic function, because the quadratic function, the first order derivative of quadratic function will be linear or piecewise linear function. So for lambda iteration method, quadratic or piecewise linear function is possible to use the lambda quadratic method. But for the complicated input-output curves, will be very hard to use the lambda iteration method. So here we developed the gradient search method. The gradient search method uses a principle that the minimum is found by taking steps in a downward directions. From any starting point x0, one finds the direction of steepest descent by computing the negative gradient of f at x0. That means you have to calculate the first order derivative of f. This is the first order derivative of f. Then you will use this first order derivative to update x. How to update the x? You just like this. The x1 equals x0 minus the first order derivative of f multiply a constant or constant factor. Okay. Alpha is a scalar or constant factor that when properly selected to guarantee the procedure converges. The best value of alpha must be determined by experiment. Okay, that means if you want to calculate fx equals 0 and you have to find x, just use the x k plus 1 equals xk minus alpha, the first order derivative of f. X. Okay, this is alpha. We just use xk plus 1 equals xk minus constant multiply the first order derivative of f. Okay. So for our economic dispatch, we have the Lagrange function like this. This is the total fuel cost. Okay, this is for the constraint. The constraint multiplies lambda, you will and plus the object function. You will got a Lagrange function like this. So the first order derivative of L over P1, P2, P3 until Pn and lambda, you will got the first order derivative like this. And you calculate L, the first order derivative of L over P1, you will get this df1 over dp1. This is for this term. Okay. For the second term, you calculate the first order derivative of P1, you will got minus lambda. Okay, so this is for dl over dp1. Similarly, you will got L over dp2. This will be dfp. How can we get the earlier part of this lecture because we just joined? Okay, in the okay, I will share this. I will share the field in next class. I will share the field in advance if you want to learn yourself before the class. Okay, and so for the first order derivative L over P2 will be df2. df2 over dp2 minus lambda. Similarly, for generator n, you will got this. The next element is the first order derivative of L over lambda. So this term is 0. Okay. So the second term, first order derivative of this will be P load minus sigma I from 1 to n pi. So based on this, you have calculated the first order derivative of L. Okay. The first order derivative of L is just a vector. You see, just a vector. Okay. It's just a vector. Okay. So we use this to update the variable. Here, the variable will be, that means that the variable will be just vector. The variable will be p1, p2, until pn, and lambda. This will be the variable, okay? And you have an initial value p1 0, p2 0, until pn 0, and this lambda 0. Okay, this is just the initial value minus alpha. You multiply delta L. What's the delta L? Delta L is this, is the delta L, okay? So that means you just update P1, P2, and Pn lambda by this, the initial value minus alpha multiply this. How to calculate delta L is just this. For derivative 1 is this expression. This is for derivative n. This is for the first order derivative of lambda. Okay, just the total generation equals total load. Okay. So let's show how to use this method. Okay. Here we have an example like this. We have 3 generators. This is the fuel cost. Okay. And also have a total load of 800 megawatt. 800 megawatt. 800 megawatt. And we set the constant, this scalar, just 1. First, we give the initial value for P1, P2, P3 equals 3. Equals 300, 200, and 300. And here you found that besides the P10, P20, Pn0, that means the initial value for the generator, we have also calculated the initial value of lambda. Here we get the initial value of lambda just as the average of this average. This is the average of these 3 generators. This is for generator 1, df1, dp1, p10. This is for generator 1. And make a summation means for the total, that means the increment rate of 3 generators, and over 3, that means the average increment cost of these 3 generators. Okay. So for df1, this part is df1, dp1. This part df2, dp2. And this part df3, dp3. Okay. So you just plus these terms, 3 terms, you will got sigma I from 1 to 3. And this is the average. So you will got the initial value of this point. Okay. Okay, let's stop here, and we will continue to show how to use how to write the program to use this method in the next class. Okay, just have a break.
Okay, 老师。
Okay, yeah. Please speak.
Okay.
Questions?
No, 老师。
Oh, okay. Let's turn back. Please, if you during this break, you can reconsider this, how to calculate the first order derivative of delta L, or how to update the solution of P1, P2, Pn by the initial value. You just based on this. Okay, just reconsider this during the break.